Okay, so we're going to be solving this rational equation, and notice how it says solve. So your answer is going to be x equals, we want to solve for x. And so, because there's no other variable anyway. So when we're looking at this, solve means it's important that it tells us that our solution is going to be x equals, and there we're going to put it in set notation. And so when we're looking at this, the main thing that we need to do is first do the extraneous solutions. So are there any extraneous solutions, which is what restrictions are? Extraneous solutions are any number that, there's various types of extraneous solutions. The ones that we're going to be focusing on right now, it's what makes the denominator 0. In this case, if I look at it, the only thing that's going to be 0 is when x is equal to 0. So we cannot have x equals to 0. So that's one of our restrictions, our extraneous solution. X cannot equal to 0. So in our solution, we need to write that as well. So our goal is to solve for x, get x by itself. So in order for us to do that, we are going to get rid of our denominators. So our goal is to get rid of every denominator. So I'm going to put this over 1 on there. And so our next step is to look for our lowest common denominator so that we could actually look at it and be able to use that. The lowest common denominator is going to make all the denominators disappear from my equation. So in this case, it's 3, 1, and x. So it's what they all need for it to cancel. I need an x for it to cancel. I need a 3, and I need a 1. So my lowest common denominator is 3x. So what we do here is we're going to take the 3x, our lowest common denominator, and multiply it through. So we're going to take this and we're going to leave the 6x minus 12 over 3 plus 4 over 1 equals to 18 over x. And we are going to multiply that through by 3x over 1, which is our lowest common denominator. We are going to distribute that to this part right there. And what you're going to get is you're going to get 3x, 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 and you're going to have 6x minus 12, because they're going to be multiplying over 3 because you distribute it. There are 2 terms here because it's being separated by a plus. If it was a minus, it'd still be 2 terms. So this is just distributing it to the first term and then distributing it to the second term. And so we have 4, and that's a plus. And then this one here is going to be 18 over x. So, okay. Now our goal is to actually reduce. So that means now, because we could cancel, this cancels with that. This one here, nothing cancels, and that x cancels with that x. So everything that we have here, it has to cancel the whole denominator. So if I didn't have 3 in my lowest common denominator, it wouldn't have canceled. If I didn't have an x in it, my lowest common denominator, that wouldn't have canceled either, this x right there. Okay, so now, we are going to take this and we're going to get x times 6x minus 12 plus 12x equals 3 times 18. So now what we have to do is actually notice how there are no more denominators, and so now we could just have to solve it the regular algebra way. So we distribute the x, and we're going to get x squared minus 12x plus 12x is equal to 54. This cancels with this one here, and so now we end up with 6x squared is equal to 54. So it is not linear, and by linear means that the degree has to be 1. Degree means the highest exponent. So let's talk a little bit about that. So the degree of any polynomial is by looking at the highest exponent. And so that means that the degree here is 2. It is not linear when the degree is 1. So we can't just go ahead and solve it any which way. We have to make sure we're solving it as a quadratic. So the degree is 2. And so we are going to solve this as a quadratic. That's the type of function it is. It's a quadratic. And when I graph it, it's going to be a parabola. Notice the difference. The graph's name is a parabola. The type of functions is a quadratic. The degree is 2. And this is the equation down here of that. When we're dealing with this type of equation, a quadratic, we are going to be dealing with 4 different ways to solve it. There are more, but the main ones we're going to focus on are 4 different ways to solve it. The first one is factoring. Second one is quadratic, because that's what it is, formula. So this formula only works on a quadratic equation. So the degree has to be 2. 3, completing the square. And 4, square root method. So those are the 4 ways we're going to be dealing. Graphing does work, but just in case you don't have a calculator or, handy or whatever, these are the 4 methods that we're actually going to be working with on there. And so we need to identify when we're going to use them. So one of the things that you need to know is that these 2 will always work, no matter what. So if I do the quadratic formula and completing the square, that will always work. And so the general format of a quadratic is going to be ax squared plus bx plus c. The a and the b are the leading coefficients, and c is, I'm sorry, not the leading, a is the leading coefficient, a and b are coefficients, and then c is a constant. It does not have a variable. This is also considered the middle term or the b term. And then this one here is the leading coefficient. So it's the leading term on there. This will always work. To do the quadratic formula, you're going to need to know what A is, what B is, and what C is. Not X on there. We don't use that to fill that in. And same thing with completing the square. We're going to use that of that format. When it's the square root method, in this case right here, the way that you identify whether you can use the square root method is that there is no middle term. So when you're applying the square root method, there is no middle term. And then factoring, that is any time you could factor when it is not prime. So if it's not prime, then you could factor, okay? So that's when you're going to be able to factor on there, okay? So here are the 4 ways to solve it. We know that this equation that we got here is a quadratic, so we need to figure out, can we factor it? Probably. Can we do the quadratic formula, complete the square? Yes. But one of the easiest ways to do it is the square root method, because there's no middle term. So if you look at that, and if I put it back the other way, 6x squared, I bring the 54 over, I only have the leading coefficient a, 6, and the constant c, negative 54. So I do not have a middle term b, so I could just actually solve it. So this is a good format to have it in, so I'm going to put it back into that format, because that's what you would do with the square root method. You solve, you move the 54 over, and then before you take the square root of both sides, that's hence called the square root method, what you want to do is divide by 6, because if you take the square root, then you're going to have to do the square root of 6, which is not a nice number. So I'm going to divide this by 6, this by 6, that's going to cancel, and I'm going to get x squared is equal to 9. Now, when you do this, now you're going to be able to take the square root. But get into the habit that anytime you do the square root, it's always going to be plus or minus. I know that when we do geometry and we find the distance formula, something that's considered a length, we don't care about the negative, so we only do the positive. But the habit is that you should always do it and then analyze, do I need the positive or do I need the negative, and then write the appropriate answer. So that way you don't forget the plus or minus, because students have a habit of doing that. Okay, so what we do now is that you're going to get x squared I'm sorry, that it cancels the x squared. And so you're going to get x is equal to plus or minus 3. And so your solution set, so that's how you solve it. You get you isolated the variable. And so your solution set is going to be negative 3 and 3. Or you could put it as um, plus or minus 3. And then we could do that. That was a very bad squiggly there. Okay, so that is your line answer. And so one more thing before we finish this, if I have x squared is equal to 9, if I do 3 squared, that equals 9, then negative 3 is equal to 9 as well. So there are two solutions. And the way that you know that is by looking at what to expect. Because the degree is 2, you should expect two solutions. Okay, so anytime that the degree is 2, you should expect two solutions. If the degree is 3, then it should be like 3 solutions. The linear ones is the degree is 1, so you always have like one solution on there. And so that is how you would solve this problem. Okay, very good.